Good day to you. It's the 21st of November. We're just 1 week from Thanksgiving here in Chico, where we just experienced a power outage. Now, today we're going to be going through a presentation on David Bohm. He's a most fascinating man, and I've read some biographical accounts of David as well as having read a lot of his books. His major book was in 1951, very well received by Einstein, and he's been a very famous physicist. He's passed now, but he's an immortal. He was one of those who broke through some of the chains of the quantum paradox. So we're going to be covering that. Now over here you'll see a LibreOffice document that I just recently composed, contemporaneously, not going to any other subject, but what I'm working on right now in this presentation series covering a new geometry is I'm attempting to get back to the mathematical basis so that you will have a full and clear depiction of what I believe is a major discovery. The discovery of a new geometry, it's an intrinsic geometry. While we're going to be looking at one of my prior videos, it was 10 months ago. It was produced in February of this year, which was quite a while ago. It's kind of serendipitous, or you could say a black swan, or a coincidence, or good luck, or synchronicity, or something like that, or just hard work. I was just perusing some of my old videos looking for clues because I'm seeking the right avenue of approach to present this geometry that I discovered with its mathematical system comprehensively. And this will be about the fifth or sixth time I've attempted to do so. My previous videos have not gotten a lot of review, that is, views, because I was unknown. But recently I've made quite a splash on a very tiny, or I should say minuscule basis. She's going to go to her perch. She just jumped up to her perch, but it was behind this document. Oh well. So without further ado, we're going to begin. It's about 100 minutes long, so it's more than an hour and a half. 100 minutes is quite a bit, but this is so critical. I was just very fortunate because the amount of work I might have expended reduplicating this effort would have been considerable. So the fact that I reviewed this video just this morning was quite a time saver, because this is exactly what I want to say. Now this is a long video because in those days, that is 10 months ago, my strategy was to bracket the entire system of science and come in comprehensively so that you could home in on the importance of what I discovered. But that's not what I'm doing right now. I'm attempting not to convince you that it's important, but to prove to you that it exists. That is, to give to you the proof that I myself rigorously composed. But I don't want to make it sound daunting. It's actually not complicated. It's just that it's what is called a fish ladder sequence. We have several paradoxes and inconsistencies in our historical development of science that has led to the current impasse. And it's very, very difficult to get past some of these jumps. They're basically jumps of logic. And when there's one, it's difficult enough if you penetrate a logical conundrum so that you can essentially reformulate the situation such that it could be proved mathematically, which means geometrically. Then you've made a major breakthrough. But in order to approach this paradox, which is the ultimate paradox ever faced by science, you actually have to penetrate a series of paradoxes. It's almost like say a tiger, although I don't like this metaphor because you shouldn't train tigers to do dangerous things, but it's like a tiger jumping through successive rings of fire. I'll be interjecting my own comments at 2 or 3 points during the presentation, but this is essentially the mathematical and geometric basis of the discovery that I made, a spherical geometry with a closed coherent number system that furnishes an amazing tool for the analysis of our current state in science. That's saying a lot. So that's why I'm being very cautious in approaching this, and I hope you enjoy this. Good day to you. This is Galactic bringing you another science presentation on this Sunday, February 18th, from Chico, California. Today we're going to be talking about the basis of science, but quite specifically, in order to acquire a new framework for science, which sounds daunting and perhaps presumptuous, but it is a suggestion which you may be able to use, a different geometry which matches physics. Currently, we use a geometry called linear geometry. Our number system constrains us to this system because our number system is a linear number system. Surely you've heard of linear algebra. It is very highly regarded, but there is a limitation. It is linear. So we're going to look at spherical geometry to see if that might grant us some insight into the current propositions in physics which form the so-called cutting edge, which I prefer to call the Fermi edge because it's a bow shock edge, not a knife edge. Now what we'll be looking at today, you'll see over to my right, but left as I'm pointing on the screen, is an empty area where we're going to have just a little bit of documentation. We're going to begin by just introducing a man whom you may or may not have heard of, who's one of the top physicists of the 20th century, a man named David Bohm. David Bohm is a very interesting man, and he has a history, that is his personal history, which to me is somewhat akin to that of Max Planck, in that they were rather tormented individuals just given this world and how one may find oneself treated in this world due to whatever factors, environmental or personal. Max Planck had quite a difficult time, although he made a tremendous discovery. Now David Bohm came later. He was about a generation after Max Planck, and he really began his famous work in quantum physics in 1951-1952, when he published a very well-received book. Certainly Albert Einstein received it well and gave it quite some compliments. We're just going to consider David Bohm for a couple of his observations in order to introduce our topic, which could be considered rather deep, but my job is to make things simple. Science is supposed to be understandable. So one could say that certain aspects of science today are not as understandable as they might be. The most famous example, of course, is quantum mechanics. But also cosmology is in serious trouble right now. You could say, especially and particularly after the discoveries, the further reaches in astronomical science, which were revealed by the James Webb Telescope, whose results in the photographs and spectrograms of the more distant galaxies, that is to bring them into higher resolution, has revealed a surface brightness relationship which can be interpreted according to the Tolman principle of the relationship between the surface brightness of galaxies and not only its distance, but if there's a model for space, such as that space is expanding, well, that is a model, that is the current reigning model. The Tolman relationship for surface brightness in very distant galaxies, this has to be high Z factor, predicts, and this has been established, that there will be a difference in the measurements. This is a prediction which science needs to be able to make in order to prove or disprove theories. A prediction is sought, which is then validated by the theory or the model, which amount to the same thing, or to disprove the theory or model thereby. That has been acquired. At long last, the cosmological model currently at the top of physics, and which has been essentially propagandized to the public who eats it up, is that the universe is expanding. An absurd statement, but you can't say it's absurd because it had been the only model. And all the challenging models, of which there essentially only was one, Sir Fred Hoyle's steady state model was defeated, uh, allegedly, with the discovery of the cosmic microwave background radiation, which totally swayed upper echelon physics, and then by trickle down, we've all been affected by it, so that now the Big Bang is considered to be an actual model, which of course, I shouldn't say of course, but superficially, it's completely absurd. However, when one only has one model, and science is always seeking a model, even for the whole universe, that has been the goal for quite a while. If there's only one model, it must be accepted, which I don't really find to be a very scientific way of doing things, but we're human. And in fact, Wikipedia states this. I did an in-depth study of how models are validated. For instance, my favorite, of course, is the natural selection model of biological evolution, another completely off-the-wall model, which is now fully accepted, of course, that we're all basically, that is, humans, are descended from the environment. This is an extrapolation on the rather, I'd say, superficially reasonable theory that the cellular organisms of Earth, which we call the ecology, although that extends to chemical and other contributory features to an overall ecology, it even goes to cosmic space, because of course the ecology depends on sunlight. But in fact, certain creatures are influenced by the moon. In other words, by the tides, which is due to the lunar gravitational effect on our oceanic system. So the ecology is a large system, not constrained just to the cellular organisms, but that of course is the nature of the ecology, given its various bases in chemistry and even indeed to the sun, of course, which is not the Earth, but it is the solar system. So the ecology is a solar system phenomenon, but its central feature is life. And humans are a specific form of life. No matter how you take that, you certainly can state it logically. And therefore, the question is, was Darwin's theory, which he basically developed from an already existing theory, but he gave it much more substance, and it was not accepted at first because, of course, a new model is difficult to accept. And especially when the Vatican, as was the case back then, still had its sway. And even though the Earth-centered solar system, which was supported by the Vatican, was overthrown essentially through the work of Copernicus and Galileo and others, that was finally faced by the Vatican Church. But then the overall system by which the universe had been systematized or given a model was still essentially the Christian, or you could say the Judeo-Christian tradition. And so there are various ways of looking at life, be they philosophical, religious, or scientific. A direct confrontation ensued following the work of Darwin, which challenged the current reigning model for the origin of life, which was strictly scriptural in the minds of most men. That has, of course, changed. Now, not to give a value to that change, it was based on presumably scientific evidence. However, Charles Darwin had no scientific evidence for his theory, and in fact there was no way he could have known that, because he knew nothing of DNA. DNA had not been discovered. So what I'm trying to draw here is a parallel between the development of two different models. And I've given lectures in the recent past, that is within the past month, comparing the three main models which govern science today, which you could say begins with the standard model of particle physics, another really strange model, because it says that everything in the universe is a particle.
Now, when you have a model, it does lead a life of its own, and now that there is such a complex society of humans, there being many more humans, and also there being technological advances that have been made to increase our communication powers, models fit right into that growth of complexity in the human organizational system, that models find a very good niche to lead a life of their own. And in all three cases, we can definitely trace the history of the model. The one we're most concerned with today is the cosmological model, because we're attempting to get at the nature of light. As you are well aware, it is the nature of light which determines the Big Bang. This does not seem at first obvious when it's stated that way. Perhaps you see the connection, I certainly hope so, but if not, it is important now to spell it out, because part of the service of science is fast summarization, because that shows a form of understanding, which now needs to be communicated, not so much to teach you, which I doubt that you need, but in order to put us all on the same page, because it is a focus of consciousness. It's a helpful way to guide a presentation. So I intend to capitalize on that now by giving a brief recount of the model that has just been overthrown by science due to the results obtained by the James Webb Telescope in showing the Tolman surface brightness exception to the standard model. And here's how it works. It does begin with the nature of light. When we take readings on distant galaxies, even to the edge of the visible universe, as was done with the James Webb Telescope and with prior telescopes, it just goes farther and farther to get better and better resolution. Well, in doing so, we're probing further and further along the Z sequence, which is a macrospace measurement system, currently the final rung on the cosmic distance ladder is the redshift distance relationship. I won't go over that. I'm sure you're well able to justify that to yourself. It has been proved that there is a distance relationship established by the Z factor, which is commonly called redshift. Now, redshift is read from the spectrogram. It's not a feature of the photograph, but the photograph and the spectrogram can be correlated, and of course they are. And these two readings, the spectrogram, which is a band of light, as you know, with lines in it called absorption and emission lines, this establishes a foreground and background whereby the lines seem to shift with distance. They shift towards the red end of the spectrum, showing an overall decrease in energy, because it's a decrease in the frequency, which is a direct measure of energy in this sense. So the redshift has a linear correlation with distance in cosmic space. I'll call this cosmic space because in local space, which would here extend to our galactic neighborhood, the redshift reading is ineffective. It's rather like carbon-14 dating. The very recent measurements do not give sufficient scope to bring out the relationship, because in more localized space it doesn't apply as systematically. But once you get beyond about the 100 parsec limit, the 100 megaparsec limit, which would be about 300 million light years. Is that right? I believe so. Anyway, our galactic space is approximately the Virgo cluster. We do find blue shifted galaxies even as far as the central region of the Virgo cluster, but after that there are no more blue shifted galaxies. Blue shift is a significant aspect of the redshift phenomenon, because it shows a certain support for an interpretation of redshift, which is based on Doppler shift. That is the current accepted interpretation of redshift, that it not only shows distance, but because of the similarity in the behavior of light in producing this effect, it is a waveform. Light is a waveform when it's traveling in space, and it does exhibit this property which can be compared with the Doppler shift of sound. And it is from the Doppler shift of sound that we get the concept of recessional velocity, which has to do with the relative motion of the observed object, or the listened to object, the heard object in the case of the train analogy for sound, that there's a change in frequency on approach velocity, and on recessional velocity, as the train is going away, one finds a pulling of the waveform so that it has lower frequency. When this analogy is applied to light, which it was very quickly done after Mach's and Doppler's research, a man named Fizeau, I believe I'm pronouncing that, it's French, so I'm not positive, I should have looked it up, I'm sorry, but Fizeau, he also studied light characteristics to see if redshift, blue shift applied to light. Well, you know from just the description of the cosmological model that indeed the model is based on this assumption that light shows Doppler redshift, which means that the apparent recessional velocity of the galaxies, which it increases with distance, is directly related to another feature of the universe. That is, that it implies directly the redshift relationship in light propagation from distant objects reveals the expansion of the universe, which is incorrect. And you should accept now that that is incorrect. But whether or not you accept that or not is not greatly important, because opinion is not really welcome in science. At the theoretical edge, it influences our viewpoint, but ultimately it cannot have an effect on the universe. We need to actually understand what the universe says, what it actually is doing. How can we measure that? We have no other theory of the origin of the universe. The steady state model actually did not say anything about the origin of the universe, except really that there was none. That's what steady state means. But it relied, in Sir Hoyle's mind, on the continuing production of matter, which is an anti-physical proposition. Well, the expansion of space is also anti-physical, but since it has support from the redshift relationship, by making the assumption that it is absolute recessional velocity, which would be due to Doppler shift, then the galaxies indeed are, it's often said they're racing away from each other, but it's more subtle than that. But the overall, it's hard to state what cosmological expansion is, but it is essentially the universe is expanding. Now, what that may or may not imply is not important, because the theory has actually been overturned. It was never really a proper theory except on an assumptive basis. That's also true of natural selection. And it just simply took extra research, which could only come about with time because of the advances in technology. Now, the James Webb Telescope is what gives us the final nail in the coffin of the cosmological model. But now we need another model. And it may not be for the origin of the universe. I will frankly state that I believe that that is out of reach. And I'm not sure how soon it might be before we could have a model of the origin of the universe, which is quite a daunting proposition. I mean, do we even have enough information? Well, without treating that subject, which is not our subject today, what we're after is the propagation of light in space and how to regard that. And in order to get at that, we need to solve the quantum paradox. So we have a lot of potential ground to cover, but we're not going to cover a lot of ground today because it has been my goal for several months now to finally get to the point, which I have been approaching, but this is a very, very difficult point to approach. This does involve the quantum paradox. For the reasons I just stated, we need to understand light propagation, light dynamics. Is there such a thing as a photon? You certainly could say there is. Certainly after Einstein seemingly proved that there is in the photoelectric effect. But there are other reasons for regarding the photon as a particle. But that cannot possibly fully explain light because light propagates as a wave. And so that is the quantum paradox, which can be stated in many ways. Very often we hear of the quantum phenomena that are most baffling, such as, well, the top of the list is entanglement, which really disturbed Einstein, basically because it violated his own relativity theory, because there would seem to be, from the phenomenon of entanglement, some violation of the absolute speed limit in the universe, although the transfer of information has never really been fully apprehended. So it's not proper to say, really, that Einstein's theory is violated. Rather, it may simply be necessary to understand what relativity actually implies about the absolute speed of light. Because it is possible, and it now seems provable, that there are transluminal phenomena, but not really. Entanglement, even though you hear a lot about Bob and Alice experiments, that's due to something that should be covered. I have covered it in prior lectures, but it's a little extraneous because it goes to non-scientific processes, why men believe what they believe. In science, that can be quite tricky at the edge. And of course, quantum entanglement is just about as edgy as you can get. But what I'm trying to say is, it's not strictly speaking a violation of relativity. It merely shows that there's a persistent relationship between two particles in an entangled state that is not mechanistic. There is no actual transfer of information at transluminal speed. It is instantaneous at any distance. That's what is now believed, and I believe this has been shown. But there's a way to explain that. That is, but it does require a different approach to science in its presuppositional approach, which is called its axiomatic basis. So, having introduced our subject with this, a large abstract framework, what we're trying to get at is the quantum paradox in order to understand light. We'll also be covering space-time, which is currently the very best formulation of, well, space-time. We'll leave it at that. So those are the two really high-order systematic results of science that we've discovered. Space-time is in some sense, a proper way to frame universal space. And this does take part in the cosmological model. It's interesting how that happens, but all this has been covered in prior lectures and needs to be covered systematically. That is the purpose of this lecture. That is, this presentation, is we now wish to home in on the solution, which does involve, according to my studies, my own research, this does require a rebasis of science, which is epical. This does not occur very often, and it would depend on how far down in the axiomatic basis system, which is an organization of perceptions. If we go all the way down to the bottom, these would be considered to be the numbers or our mathematical system. But actually, I've shown, and it's really has been known, I am simply bringing out more clearly that our number system is based on geometry. And geometry is our perceptual mode as humans. We don't perceive numbers directly. We use numbers to interpret what we see, but what we see that can be understood scientifically is called structure. It's structure. It's not, strictly speaking, just physical structure. There is more than one kind of structure to reality. We as humans know that painfully well because we have an emotional system which forces us into a structuralized view of the universe that does not have much to do with logic. It obeys a different system. And just to give you a small or brief indication of how profound that statement is, our emotional system includes love. Love, joy, fun, also fear, and other negative emotions, but it's generally conceded that humans, at their best, when we're happiest, our lives are governed by love. But that's not science. Well, not yet. I mean, now, the man I wish to utilize the services of a specific man to introduce our topic, which will be quite specific. This is no longer going to be abstract. I've given enough bracketing information, which is far-ranging, because to get a rebasis of science, you really do have to justify what you're doing. This will be an extension to our number system, and in fact a new geometry. So, I know, but let's introduce this with a man I think you may have heard of, a man named David Bohm. There he is. David Bohm represents to me, now that I've read some of his writings and know a lot about this man himself, that is his history, he embodies to me the situation, certainly in quantum mechanics today. Which is what? What am I trying to point out? We do have a paradox, so we do need a new approach to this paradox in order to solve it. But how this goes to philosophy now, in the confrontation, which I believe, well, to me is the celebrated confrontation between Tim Maudlin, who's a philosopher of science in New York, and Bernardo Kastrup, who's a CERN physicist, but he's also a philosopher of science. Both of these men have degrees in that subject. And I remember when I first became aware of Tim Maudlin in the comments to the video, where I was watching Tim Maudlin because I like his approach. It's an ontological approach, and if you don't know what that means, don't worry. But he takes an ontological approach to the quantum mechanical paradox. And while I was listening to an interview where he was being interviewed, in the comments, which the viewers are allowed to leave in YouTube, there was a little flurry of excitement when one gentleman, person, suggested that it's time for Tim Maudlin to meet Bernardo Kastrup. And I'd never heard the name Bernardo Kastrup, so forgive me for those of you who may be fans of Bernardo Kastrup. Kastrup has a cult following. It's been called that. Oh, that's a bit prejudicial. A cult? Wow. Well, that's how it goes with quantum mechanics these days. Everyone is looking for the right framework in order to explain quantum phenomena, which have not been explained for a century. So that's what I'm going to do today, is explain the quantum paradox so that you have a better framework for understanding it. This has never been done. So, why do I introduce David Bohm? It's because he takes one of two points of view on the quantum paradox, which is somewhat hybrid. And he certainly has a right to do so. His book, which came out in 1951, which Einstein liked, was about quantum mechanics. Very well received. But very shortly thereafter, still in the 1950s, David Bohm changed his mind and went to the other camp, which was not mechanistic. And this is where Tim Maudlin and Bernardo Kastrup come in, because they represent two antithetical, they shouldn't be called antithetical, but they're treated as being antithetical, because in science you really should only have one way to approach things. Logically, there should be one answer. Well, maybe or maybe not in the case of quantum mechanics, since no one is sure, but Tim Maudlin takes a mechanistic point of view, and in the mechanistic point of view, you can either take the Copenhagen school of approach, which is shut up and compute, according to David Mermin, allegedly. But that simply means that you can get the first state and the second state and don't worry about what's in between. Well, Albert Einstein is the man who first, the most celebrated name of those who said, you can't leave out what's in between. You have to know what happens in between. Well, that's the quantum paradox, is what happens in between two measured states. That's one way of stating the quantum paradox. Now, David Bohm knew all about that. He knew that the Schrödinger equation works predictively to get from one state to the next. So does the Dirac equation, which is the relativistic form. I believe that's fair to say. But both of them are considered to be mechanistically correct because they make very good predictions. What that leaves out is the structure. That is, there's no geometry. And that's been pointed out explicitly with that word, geometry, although not very often, because geometry has fallen into disfavor for reasons which I've covered in prior lectures. Now, what David Bohm does in his whole life, that is from 1951 on, is he shows how a man can be converted to the other side. Now, not to switch back and forth so often as to make you dizzy, but Tim Maudlin essentially takes a mechanistic approach. But in his mechanistic approach, he's looking for what is happening, which is, according to his own terminology, an ontological approach. That is the opposite of epistemological, although they go together. They're more dual. Ontologic means the structure itself. But epistemological, an approach to mechanics, is the process itself. So in the epistemological approach, you have the Copenhagen theorem, or the Copenhagen school. It's not a theorem, it's really a philosophy to deal with actual measured phenomena, actual measured events. And that is the nature of the difference between ontology, which is really the structure. That is not just event A and event B, where you jump. It's really a quantum jump from one measurement to another. But what is desired to fill out the entire picture for understanding is what happened. And that's where the paradox is. It's in between the two measured states is a structure that has not been discovered. I discovered it, though. So that's what I'm going to convey to you today, is the actual structure that solves the quantum paradox. Now, whenever you achieve a solution in science, I believe it's important to, if not state, at least imply what you're saying. It's not the absolute answer, that those are going to be forever far off. But certain things can be established to a new threshold, and that's what we seek, is a new threshold of understanding of quantum mechanics. So in the approach preferred by not Bernardo Kastrup, but Tim Maudlin, prefers the mechanistic approach, which accepts that the two measurements, in the simplest case, state A and state B, that's enough. Although what he wants is to find the structure. That is what we all want to find. Now, what Bernardo Kastrup says is epistemological, and he's simply commenting on the situation the way it is. What Bernardo hates in the mechanistic approach to quantum mechanics is that it allows such theorization as the many-worlds theorem, which is essentially to split the universe itself, which, of course, is rather ridiculous sounding. Well, Tim Maudlin does not think that that's ridiculous, and he certainly is not alone. But this is what gives rise to a lot of the spookiness, which is attractive to a general, I'll just say, low common denominator audience that is not trained in this area, so we're just listening. We're more fascinated with the philosophical approach to this. And so I introduce my topic today by pointing over here to this big picture of David Bohm, and I think you may recognize the man who's smiling over David's left shoulder. That is His Holiness the Dalai Lama, and they have had conversations. So so David Bohm not only jumped off the mechanistic shut up and compute bandwagon, he really went all the way into the area that Bernardo Kastrup prefers, which is far more philosophical, because it gets down to how we know things. I don't like going into that area because it's a fringe of science, but we're already at the fringe of science. So I'm not saying that one man is better than another, and I'm not saying that David Bohm has the exact right approach. I have the exact right approach, but in order to introduce it, it's important to me to be sure that you and I are on the same page in how difficult this had been to achieve the discovery that I did. And it was not easy for me, and it could not be, because look at the minds that have been foiled by the quantum paradigm. All the minds have been foiled by it. Nobody has ever understood it. Okay, so the reason I show that the Dalai Lama is leaning over David Bohm's shoulder is because David wrote a book which I am very much looking forward to reading. I have not read David Bohm's later book, and I'm not even going to name it because I want to show you something that I think you're going to find interesting, which is, hope I find this, I will, hold on, here it is. This is from Wiki Quotes, and these are quotes of David Bohm. I'm just going to read the top one. It's the first and last clause that are the most important. There is no reason why an extra-physical general principle is necessarily to be avoided. That's already a bit of a complexity, isn't it? There is no reason why an extra-physical, outside of physics, there's no reason to avoid philosophy, is what he's saying. There's no reason to avoid a philosophical approach, since such an approach could conceivably serve as a working hypothesis. I accept that, but it's rather abstract. And it's also, it opens a pretty big door, which usually science does not like to leave open. We don't want philosophy if we can avoid it. What David is saying is we may not be able to avoid it. I wish to correct David on that. The correct word is being overlooked. it's not philosophy that's missing, it's geometry, which actually serves as this extra physical principle, but it's not extra physical. Geometry is considered now to be too non-numeric. And so geometry has somewhat been lost from view. Well, it's just coincidental, I guess you'd have to say. That's what is missing from quantum mechanics is not philosophy. It's geometry. That's what I discovered. So, to continue and just complete this, for the history of scientific research is full of examples in which it was fruitful indeed to assume that certain objects or elements might be real long before any procedures were known which would permit them to be observed directly. This is what I wanted you to hear, to consider with me now what David just said. This is quite a bit different from the first sentence. What he's saying is that we can assume that certain constructs are valid even if we can't measure them yet, that we can predict that they will be discovered. That was done by Ruger Joseph Bošković, whose book I read, and I've read every possible piece of information or documentation about this man, because his name has arrived. He did make predictions about particles, and this is the certain objects or elements that might be considered real, because it's fruitful indeed to assume that such objects or elements might be real, even though you have not yet observed them directly. These would be the particles of Ruger Joseph Bošković. And that is the connection that I wanted you to obtain. This is not just something from my fantasy. This new approach is indicated, and we're going to be using the work of Ruger Joseph Bošković because he actually got the algebra and the structure of the Bohr atom before the Bohr atom was discovered, well over a century before the electron was discovered and the proton was discovered later. We're going to cover those two objects today. Now I would like you to see something else. This will be a document that I composed, as you could see, today. And at the top of this page, you'll see there's a link. And that's a link to a book, which is by a man named Nichols, called The Bohm Reader. I believe that's the title. And I've been reading the introduction to that, which I believe you would find interesting. And now I'm going to take a gamble here by plugging in that link so that you can see the online copy of this book that you can read for free. And you can download this as a free PDF file. There's our paste and go. And there it is. I'm sorry, The Essential David Bohm, edited by Lee Nichol. And you can't see that yet, but you will in a moment. There it is. And from here, I would like you to just see a brief section of this, because I think this will unify the bracketing information that I've been giving you rather windedly thus far, and I apologize for that, but see, oh, I'm sorry. Let me do this right. I'm getting over to that document, and there it is. Now down here, We have some introductory material, the title page. This is a very nice poem by Gerard Manley Hopkins, or Gerard, however that's pronounced. And here we have the contents, and finally, looky here, we're just gonna, there's the acknowledgments and a reminiscence about David Bohm. I want to read this, and you'll enjoy this, I trust. David Bohm, just want to be sure you can see this. Yeah, you can, good. David Bohm was a scientist well known for his work in quantum physics. I met him on several occasions, and my personal impression of him as a human being was that although he was a famous scientist, he was neither arrogant nor proud. Take careful note of that. On the contrary, he was humble and easy to talk to. This is the mark of a true scientist, okay? Not Neil deGrasse Tyson. He's not humble. He's not easy to talk to. He's arrogant and proud. Well, so was Bernardo Kastrup, and so was Tim Maudlin. And that closes that story. True to his scientific training, he was unbiased and open-minded, another sign of a true scientist. Consequently, although he was mostly focused on his own field of scientific research, he was also interested in consciousness because of its implications with regard to the theories of quantum physics. Therefore, he also showed interest in some of the ancient Indian schools of philosophy. He seems to have known Krishnamurti quite well, yes he did, and had stimulating interactions with him. When we met, he would ask about the Buddhist concept of interdependence and the corresponding theory of emptiness. For my part, I had the opportunity to listen to him explain quantum physics on a number of occasions, and I made some effort to understand these difficult ideas. Because he was the one I could question in detail about quantum mechanics, I consider him to have been one of my scientific gurus. That was written by the Dalai Lama. So, here is what I wrote today, essentially beginning what will be a LaTeX document for submittal to Archive once I have this polished, which I estimate will take 3 to 6 months. Not because the information is collected, it all is collected, but to present this in a way that does justice to what the Dalai Lama said about David Bohm. That I want to be regarded that way. I am not starting a fight. I'm not Tim Maudlin or Bernardo Kastrup. And I have no vested interest in the results of scientific inquiry. I'm not employed by the industry. I am beholden to no man. So, in beginning a science conversation in our cosmic field, we may choose any number of dual points. I'd like to explain that because I believe that requires explanation. When I say our cosmic field, I say that rather than saying cosmological. And the reason is that when we're talking about our cosmic field, the way I say it, that includes quantum mechanics. Why? That's not astronomy. No, it's not astronomy. What it is, though, is the nature of light. And that's where we get all of our information about heaven, which is a synonym in some, depending on how you understand the word heaven. I like to say the word heaven because of the Dalai Lama's point of view on David Bohm. I'm not leaving out anything that humans experience. We need everything that we know in order to understand reality. And I can assure you, it is not based in science. So why would I concentrate on science if I feel that way? Am I going the way of David Bohm? No. I did everything in reverse in that respect. And I'm going to leave it at that. In beginning a science conversation in our cosmic field, which is quantum mechanics and cosmology, and everything in between. In other words, we're covering the basis of science and physics itself. That's our cosmic field. From the edge of spatial infinity to the inner limit of the quantum paradox, we need both ends to know anything in between if we're going to have a correct basis of physics. Because that's the realm of physics, from the inner product, and that's an algebraic term, but accept that, to the outer product, which is spatial infinity, at least. But it also includes a concept of time, which also has infinities involved. We're going to be covering that today, right now. This will go over an hour. I estimate that this may run to 2 hours. So if you need a break, I'm going to be putting in break points so that you can get a cup of tea. Just put this on pause at some logical point. I just want to remind you, you're not constrained to watch this in one sitting. I am constrained to give it in one sitting because of the nature of communication in science, especially at this level, requires continuity. I must not break the flow. So, in beginning a science conversation in our cosmic field, we may choose any number of dual points. When I say dual point, I'm talking about something like electricity and magnetism, which are dual, or in the simplest case in geometry, dealing with spherical geometry, you have dual points on the sphere, and there are only two. There is the center to the sphere, and there's the edge. If you conceive of that as the universe, well, first of all, you're going to have two problems. But you can conceive of the universe geometrically, if you wish, just to take a look and see if it leads anywhere. Just consider the universe to be a sphere. Well, it has two poles. It has a dual point, or a dual pole. A sphere has a center. It's the definition of a sphere, except with just the center, that would be perhaps a point. And in fact, that's what it's called in geometry. It's the spherical point center. But that directly implies the other pole, which is the edge. Which is not a pole, is it? Because it's not a point. It's more like, you know what it is? It's a closed line. Although that would be called a sphere, and in fact, we don't know if it's closed or not. If it were closed, our universe would be finite. And if it were a spherical universe, it would be closed on a spherical surface. We have not discovered that yet. So there's an infinity, and infinity is real. It's real, but it's imaginary. And how can I say that? Is that proper to say? It does depend on how you define imaginary, and in fact it depends on how you define infinity. Infinity cannot be defined because it involves a logical contradiction even to state what it is. It's that which is beyond the edge. That is, of course, a circular argument. Actually, it's a recursion. It's an infinite regression, is another way to put it. Because if you have an edge, then you do have something beyond the edge. But if you have something beyond the edge, your edge is not an edge. And this is the turtles that go all the way down. The turtles that go all the way down, I've heard this stated many times. It's supposed to be a catch-all for this is a paradox that's just weirder than weird. No, in science we actually have to understand the turtles all the way down. We have to know exactly what those turtles are, what they mean, and what kind of a construct that is. I have that solution to the turtles all the way down problem. I have defined infinity rationally for the first time. So that's part of my presentation. There's much more though, so let's go on. That's what I mean by dual point. That we could begin a conversation in cosmic science, which includes quantum mechanics. So, well, where do you begin then? Well, you can begin at the center. That would be the quantum paradox. That's the center. Because we can't find it. We've never found a center. That's why one way of stating why we don't know that the universe is spherical. The other pole in this duality is the edge. Well, that's physical infinity. So you could start there. That would be cosmology, essentially, going out to in. That is to embrace the whole thing from out to in. Well, that's the cosmological model. That's what it is. That's what it intends to describe, is from out to in. And you know what that implies, so I don't need to go on. But that's what I mean by a dual point. You can begin at the edge, or you can begin at the center. You can begin talking about spatial infinity. I found it necessary to direct my attention there. Or you could begin at the center, the quantum paradox. Also not understood. You could begin at either edge, the center or the edge. Is the center an edge? Yeah, it's the quantum paradox, exactly. All right, so paradoxes are useful for disarming mechanistic conceits. That's exactly how I intended to introduce the David, is it David? Oh, I'm sorry, Tim Maudlin. The Tim Maudlin Bernardo Kastrup debate, just to wrap up that little story. If you haven't seen that video, it's on the Kurt Jai show. And I have a video devoted, actually 2 videos devoted to this meeting of minds. After I noted that it was suggested by a commentator that it's about time that Tim Maudlin and Bernardo Kastrup met, well, I had to look up Bernardo Kastrup's name and find out, because he was being compared to someone whom I was following for insight, which is Tim Maudlin, whom I still respect, no matter what happened in his debate with Bernardo Kastrup. But Bernardo is really on the ball, and he's very much like David Bohm, in the sense that he wants a more philosophical approach to science because of the quantum paradox. He's saying, essentially, he doesn't buy the many worlds theorem, which no rational man should, because it says that the universe splits. And that's how to describe what happens in between measurement A and measurement B, that the universe splits so that Schrodinger's cat is both alive and unconscious at the same time. That is, awake and unconscious. I like to say alive and dead. How about just knock the fucking thing out instead of killing it? Well, it's because the man who invented that paradox, Schrodinger, he loved cats. And so he's trying to shock the hell out of anybody who read this, because he was saying, you better understand this better. Otherwise, the cat is alive and dead at the same time. All right, let's go on. When speaking of the universe as such, we prefer, that is, I prefer, to introduce this topic with spherical spatial infinity. That is, I prefer to start at the outer edge. I'm not saying that's where I'm going to start today. I'm saying in a general meeting of minds, whether it be a panel or just a face-to-face confrontation, that's where I would prefer to begin, because it's necessary to find out a common ground on how a scientist looks at spatial infinity. How do you deal with that? It's just my preference, but it's one I found it to be useful. So I prefer that, so as to force the topic to a solution prior to entertaining the pedestrian superstitions so commonly offered by industrial physicists. Now that rather pointed comment is meant to discard the standard models, because they have evolved artificially and have become ossified so that the models are controlling how we look at things, and that's never good. So that's just the bracketing information there. Then the topic can be turned to effect by introducing the spherical number system. This is what I discovered, and it solves that paradox. On the other hand, when dealing with the delusional system of quantum mechanics, it deludes everybody, so that's not an unfair statement. the topic can be turned back into scientific lines by introducing the proton as the only space particle, leading into the more logical framework that deals with the electron by its correct definition. In both cases, the inner and outer limits of mechanistic conceit, the subject can be steered into the correct framework for physics at these boundaries. What I'm saying here in short is that in order to get a rebasis of physics that we need now to understand cosmology and to understand quantum phenomena, we need to deal with those at the same time. They're related, and that's the essential structural nature of my discovery. It's not just a new geometry, and it's not just a new number system that extends the linear number system. These are not games. This is actually discovering how the universe is talking to us. Because in the construction of spherical space that I've accomplished, it's now proved I have done this, although consensual science has not had its say yet, so I can't say that this is proved in that sense. It's proved in my own mind. It actually solves the nature of spatial infinity, logically and rationally. So we now have for the first time a rational definition of spatial infinity. But more than that, what is this framework? What is that framework of which I speak? It is a geometry. To find the framework for physics, one can subjugate the measurement prediction subsystem, that's mechanics, into its proper context. The only way to axiomatize physics is with geometry. Now, as I pointed out at the beginning of this presentation, physics is axiomatized on a geometry, and there's only one. It's the line. It's the linear system, which can be 1D, 2D, which is a plane, or 3D, which is cubic space. If you add a fourth line, it's hypercubic space, and that's Einsteinian spacetime, is a hypercubic system. That simply cannot work, and that's what I'll be showing as well. We'll be getting into that as well. To begin with a numeric approach binds the framework to the linear number system. That's because it's the only number system we have. We, in other words, require a new number system. I discovered that. And it has to be an extension of the linear number system. It can't be properly new in that sense. Fortunately, that is easily provable, and I've done so, and that's why I'm submitting this document to Archive, because essentially this offers a brand new framework for physics, going far beyond what David Heston has brought out in his discovery of the usefulness of geometric algebra, which I used to think was the proper cutting edge to get at these paradoxes, that geometric algebra would offer a solution. And I was disillusioned after a while, after investigating geometric algebra in huge, great depth, that the only problem with it, it really is not bad at all, because it's the best formulation of linear geometry. But alas, it's still linear. So geometric algebra still relies on the linear number system axiomatic basis of all science. That is, our number system and our geometry are identical. They're identical. And that was proved by John Horton Conway in my lifetime, before he died of the COVID virus about 4 years ago. So this is an introduction for you to some of my teachers who've led me on this path of discovery. Now, the only way to axiomatize physics is with geometry. I have proved that. To begin with a numeric approach binds the framework to, I'll just say, the current numeric system, of which there's only one, the linear number system. In order to deal with this conundrum, we must obtain somehow a mathematical way to address curvature. It's curvature that we need to get at. We all know that because gravity is a curvature phenomenon, although there is such a thing as a force line. That shows that the linear system is embedded in spherical systematization. That when you create a spherical geometry correctly, the line is embedded in it. That's shown physically. That's a physical relationship. So that's very important, is that we're trying to get at curvature. Well, we can't. Curvature is outside the linear system. Because the curve must go between two lines. Essentially, it's never linear. That's the definition of curvature, is that it's not linear. So, that's pretty obvious, but it's necessary to state these obvious things. For one thing, you can find out if you've made a mistake later, because you explicitly state what your insight is. And I may be convincing myself of something that is unreal. That happens all the time in science. And then you submit your discovery or your insight to other scientists, and they can see your error and point it out to you. Now, that could lead to an argument. It certainly did between Bernardo Kastrup and Tim Maudlin. They talked they didn't get past the introduction. Kirchai Mungel introduced Bernardo Kastrup first, and Bernardo gave his introduction to his really philosophical point of view of quantum mechanics. And then Tim Maudlin was kindly introduced to give his response, and Tim shot Bernardo in the foot. One of the most unprofessional, unscientific things I've ever seen done at that level. And it's very tragic what Tim tried to do. And so Tim disqualified himself from the entire sequence. And once he was done making fun of Bernardo himself, he called him silly and he called him stupid. And when then Kurt turned back to Bernardo, Bernardo said, "I'm out of here." And Tim's reply to that was, "Ciao, buddy." In other words, condescending. He dismissed Bernardo Kastrup. Then why did Tim even show up if that's all he was going to do? Silly, stupid. Unbelievable. Anyway, I never want to do that. Although I have. Because it gets emotional. Because of my angle on things. I come from the opposite side of the funnel. I really have approached life, for I would say the first half of my life was devoted not to science at all. It was to philosophy. Absolutely to philosophy. With religion. Religion is a form of philosophy because it's not science. Because it's not entirely based on rational principles, although it is, but not in the same rigorous sense. And that's where we get the mechanistic approach, is to avoid superstition. But what you don't want to avoid is supernaturality, because that may be implied by the system itself, that there is a supernatural aspect. Well, we simply don't like that in science, for reasons, and I think we all know what the reasons are. All right. So in order to deal with this conundrum, we must somehow obtain a mathematical way to address curvature, which is the more general class that includes sphericity. Sphericity is really the ultimate normalization of curvature. You're no longer dealing with a family of ellipses and hyperbole and the boundary condition, which is the parabola. You're dealing with it's basically the unit of structure, because it's the simplest. All right, so that's why we want sphericity. The correct number system for spheric space was discovered to be the proportional number system. That's profound, but I'm not going into detail here. Using the two basis theorems, these are my theorems, to axiomatize the system, which is the spheric system, we find for the first time a rational basis for considering physical spatial infinity. It is indeed a proportional number that solves that mystery. It's not precisely a mechanistic way, since this is pure structure, but it's the equivalent of a mechanistic approach using geometry. That is, you're not any longer relying implicitly on the geometry that you think you're stuck with, which is linear, which can't work for reasons I've already stated so many times. It would be much to be preferred if you could get it to get a spherical geometry that has a spherical number system, but it would have to be composed of linear numbers. In other words, a higher order of linear numbers, well, those are proportional numbers. And what are those? We call them fractions. And the discovery I made in the proportional number system, as this was emerging in my mind, that one of the numbers has to be 1. So in the case of infinity, to make that a proportional number, in other words, to delinearize it, I guess you could say that, since any conception of infinity would have to be linear, since that's the only number system we have, and infinity is a quantity in that's by force. Well, what if we were looking at the universe spherically rather than linearly, and we simply give a number to infinity, the edge? Well, that would be infinity. Not exactly, it has to be a proportional number. So it's infinity over 1, and that is the first rational definition of infinity that has ever been given in the history of science. But what does it mean? That really has no usefulness. Actually, it does. If you realize that since it's a proportional number, it has a reciprocal, which is 1 over infinity. That turns out to be the geometric definition of the quantum for space. And it leads to the quantum of energy, which is the quantum of motion, which is the quantum of time. And so there are 2 quantums. I'm not saying quanta. There are 2 quantums. One of space and one of... We'll get to that. So using the 2 basis theorems to axiomatize the system, we find that we are able to define infinity, and at the other pole of spheric space, the center, we find the absolute definition of the quantum in both of its paradoxical forms. And it is a dual paradox. The nature of that paradox I've discovered, and it may be a general principle, when you have a paradox, you have 2. And if you can find both paradoxes, you might be able to relate them. And in this case, they certainly have been related. So there's more here. Let's go on. Given then this rebasis of mathematics, we are relieved of the inconsistency in the linear number system when it is reduced to its single operator status. What I proved, which I am certain that nobody else has ever even thought of, is that the line only has 1 operator. Now, of course, that must come as a surprise to mathematicians. What operator of the 4 do I mean? It's add. And that's actually self-evident, and that's one of the problems. It's so self-evident that it's been overlooked that multiply and divide are not linear operators. We're taught that in school. Every mathematician on earth would say that they are linear operators, but they're not. They operate in proportional space, and only in proportional space. This is multiply and divide. The proof of that, there are several proofs of why the linear number system cannot address proportional space, is because of the nature of the linear center, which must be 0 in order to establish our number system. That's been rigorously proved. And so when the line is reduced to its single operator status, that frees up multiply and divide. Those are a twin operator. Just as add and subtract, that's 1 operator for the line. The multiply-divide system is for spherical space. Given then that the additive identity is localized to its geometric space, that's 0. We localize the multiplicative identity to its true geometric position as the center of spheric space, and that's a mind bender. I believe that this is the main reason that nobody ever discovered this relationship between the number system and the object to which it pertains. It's because of this center. It would have to be 1 over infinity, right? That would be the center of the sphere. If the edge is infinity over 1, then the center is not 0. Well, what is it? It would be the smallest number to the proportion that infinity over 1 is the biggest number, then 1 over infinity is the smallest number. In calculus, that's called the infinitesimal, and that's the solution to a lot. So to go on, we localize the multiplicative identity as the center of spheric space, 1 over infinity. Firstly, this is a closed mathematics system. That's true. Multiply and divide are not closed on the line. And to complete my former sentence, one of the main proofs that the multiplicative divisional operator, it's a single operator because each operator has an inverse. Add has subtract, and multiply has divide. Actually, you should say it the other way around. Divide, which is a proportion, that's a proportional relationship between the two numbers in a fraction. Like if you say that light speed is something, well, you mean that's a certain distance proportional to a certain amount of time. And the inverse of that operation is multiply. And that's what gives us the multiplicative identity. That if instead of adding the two linear infinities to 0, you multiply the two spherical infinities to 1, and that produces a sphere. That's probably the greatest discovery in the history of mathematics or geometry or physics, as I will be showing. So this is enchanted ground. You're going to see quite a few more paradoxes being solved as we investigate this system, but the one that we're after is the photon. We need to understand the wave-particle duality. I state, because I can prove, there is only one way to do that. And that's with the rebasis of the entire axiomatic basis of science, except for the value of the computational numbers. The computable numbers are the linear numbers, and that's why we can't get rid of them. So it has to be embedded in the spherical number system. I've rigorously proved that the linear number system is embedded in the spherical number system. And the linear number system not only is embedded in everything, but the linear numbers are extractable. And the way to extract the linear numbers, this is the same essential operation that's required for the complex number system, that at the end of your complex number manipulation, your algebra, the last step you have to extract the linear numbers because I is not computable. And so you use conjugate algebra in order to extract the linear numbers from the complex numbers in a fully coherent way. And this is the magic and miracle of complex numbers. But it's linear. It's actually hybrid. All right, to go on, I don't want to get on any one of these tacks for too long because already we're at 1 hour and 20 minutes. I want this to be less than 2 hours. But now might be a time for you to take a break, get some refreshment. I'll just demonstrate to you that I also need this. Here we go. And yes, this is my medicine water for the day. Hop Hunter. Now I'm on the hard stuff now. Brewed with distilled hop oil. These are medicinal. I'm a Native American, and I consider this to be medicine water, okay? So live with it. I have to. You're going to enjoy the rest of this, don't worry. This should be entertaining. You're not here for rigor like get to work. No. Science is supposed to be fun. I claim this is the most fun a man can have. But you have to be logical. You have to follow the rules. It's like playing any other game. Well, if you break the rules, well, is that fun? No, it's not fun. That's why we have referees. Like Kurtjai Mungal, who could not stop the carnage anyway. Because both Tim Maudlin and Kurtjai Mungal were just ready to break the rules. I blame Tim since he drew first blood. But Kurt actually, well, not Kurt, I mean, Bernardo did set himself up. Because he must have known that he was going to antagonize Tim with certain ways that he put things. But then it came out. I can justify that in retrospect. As far as motive goes, it wasn't just Tim. Because after Tim called him silly, and then said he's stupid, and then really stupid, it's just like 3 times, oh my god. And then Kurtjai Mungal, was kind of like, hey Bernardo, what do you think now? And Bernardo, no, I don't like this way. And he turned tail like a little bunny rabbit and ran away. He didn't have to. He could have stood his ground and just said, well, Tim has his way of looking at things where he feels like he can call people stupid and silly, and then just continue. He didn't. He turned coward and ran away. But as he was replying, and he was quite discomfited by Tim's insane attitude, that Bernardo called him stupid. So that's how it ended. One more sip and we'll get back on track. And you may have had time to read this. It's a closed mathematical system. It is. Secondly, it subjugates the linear number system to being a subspace of the proportional number space on the standard integral derivative transform. That is calculus. So instead of needing multivariable calculus, instead of needing various forms of calculus, you only need the simplest calculus transform to get the linear numbers out of spheric space. Because that's what the calculus is actually for, is to get a curvature. I'm sure that you know that, but that is a profound thing to say. You no longer need calculus with a spherical number system. I would call that perhaps a side benefit of the highest order. There's more. This in turn reduces the need for calculus to a single simple step. This also eliminates the need for the cosine-sine split system. It also eliminates the need for the hybrid complex number system. That's quite a few nightmares that are pushed out of the way. So I hope, you see, you have 2 possible reactions now. Either you're like, this just sounds like the Holy Grail, or you might react, this sounds like, a cartload of poo-poo. Try to stay humble and keep listening. Don't make judgments either way until there's a consensual response. That's why I'm publishing. Okay, probably by midsummer. It also eliminates the need for the hybrid complex number system. Finally, since this is a closed mathematics system in spheric space, the problem of the geometric singularity is removed, as there is no division by 0, as there is no 0. 0 is a derivative number. That it has been proved by me. So, we are then able to substantiate the fundamental force duality inherent in physics. This is a new topic. I'm sure where does that come from? This has to do with Ruđer Bošković's work, which I was very, very blessed to discover. Halfway through my discovery sequence, I just kept running into Bošković's name. Another story for another time. That's in previous lectures. But this man is something else, okay? He lived 250 years ago. And he talked about a 2-force system in the universe, whereas Newton only talked about centripetal force, which we call gravity. Ruger did him better. What I'm able to say is Ruger was thinking in spherical geometry. He had to be, or he could not have seen this. He actually described the Bohr atom 150 years before the Bohr atom was discovered. That's incredible. He's never been refuted or even challenged, not by anybody. And yet he has an algebraic curve that describes the relation of the electronic shell system to the protonic core. And he does it without calculus. I know all about it, so don't worry. That's why I'm writing this paper, yes. We then can replace, let me read that again. We then are able to substantiate the fundamental force duality. I discovered the other force name. Gravity is known as centripetal force, that's a given. But nobody has ever discovered centrifugal force in the intrinsic structure of the universe. I discovered it. It explains the electron, and it leads directly to the solution of the photonic paradox, which is part of the quantum paradox system. All right, we then can replace the single force Newtonian system using the Noether force symmetry to establish the dual force system of Boschkovich. This in turn enables us to rebase the standard model of particle physics, re-axiomatizing it to a two-particle system whose particles have a distinct geometric relationship. From further consideration of the newly established spheric geometry with its closed, consistent, complete mathematic basis, we obtain for the first time a proper conceptualization of the proton and the electron, solving a whole list of paradoxes, including the quantum paradox. For now we find that the proton is the quantum of gravity, that's centripetal force, and the electron is the quantum of motion, that's centrifugal force. Finally, from these simple theorems, we arrive at a logically coherent definition of time, enabling a geometric reconstruction of spacetime. That's saying a lot, but I had finally to get around to this. I hope you're not turning me off because that just sounds too good to be true. With a new definition of the finite universe, we also discover the true role of spatial infinity, that it implies a spatial contradomain. You can't just throw out infinity. I have proved that the universe can be conceived, it can be constructed as a finite system. However, in doing so, that creates imaginary space. Because what's beyond the edge? That is the definition of imaginary space. That is the correct use of the term in physics and in mathematics. It's a geometric term. That imaginary space is the exact correct name for the space beyond the edge of infinity. And that's a monumental, almost science fiction-like statement, but it's not philosophy. Thereby, we are introduced to a notion of hypersphericity. This is the solution for space-time with all of its drawbacks. Because it was linear, it could not quite get things right. But it did use a four-number system, which is very important. It turns out that hyperspherical space is also a four-number system, but with all the numbers in relationships. In space-time, it's a 3-1 split on space and time. That's asymmetrical. But in hyperspheric space, it's a 2-2 split. We'll be getting into that in incredible detail because this is a discovery vector. Anyone who embarks on this path will make discoveries of incredible importance. This is just the beginning. So, I'm sorry, but I am excited. Okay. We're introduced to a notion of hypersphericity, which is a two-sphere overlay. It's very simple, but it does account for centrifugality and centripetality and imaginarity, and the inner product, outer product conundrum. All of this is solved with the right geometry. Then, at long last, rationalizing a necessary imaginary space to compensate for the infinite extent, I misspelled that, that's all right, of perceptual space. We cannot see infinity. Well, we can't see the quantum either. We're getting there. Then the dualized nature of spheric space permits a rebasis of physics that defines the paradoxical nature of both the proton and the electron. You may be aware that all quantum phenomena have to do with either the electron or the photon. There has never yet been a quantum paradox suggested for the proton. And there's a reason for that. And actually, there's also a footnote to that, as often there is in science. But this is just summary, and we're at an hour and a half. We may be able to close this off at an hour and 40 minutes. I hope you're enjoying this so far. I guarantee you I am, because I've been trying to get this out for 2 years. That's why I've made 440 lectures so far, is to make sure that I stay on track in my ability to present these incredible, intrinsic insights that solve so many of our problems in physics, and indeed in mathematics. So you see why I enjoy geometry, I hope. These two particles are proportionally inverse in physical effect. I discovered that. The definition of this relation is found in spheric orthogonality. Ruger-Boschkovich proves that I'm right, for which Einstein found the linear solution. You must always remember that the Einstein field equation, basically establishing general relativity and giving us space-time, is a linear solution. All right? That's why it's so filled with calculus. All right. I hope you understand that. I'm sure you do. At least intuitively. But we'll get into that more, as I've gotten into this in many of my lectures in the past. So, the linear solution embodied in the Einstein field equation for general relativity using spacetime is so crippled as to be unusable except by supercomputers. That's referring to the calculus. And so geometrically involute as to require pseudo-hyperbolic geometry. He's a cinching cosh if you like that shit. Finally, the role of time is found to be only relative, and this misses its true nature. A time actually is misconceived in the Einstein formula, and there's actually no such thing as space-time. That's because time, there's a reason why it's so baffling to the human mind at the outset, that you're mixing the characteristics of time with space. Well, you missed the point. You got it wrong. Einstein got it wrong. Of course he got it wrong. He's using linear concepts where we know that at least something in this is not linear. Well, you can compensate for that with calculus, but you'll never understand it. You actually have to see it geometrically correctly. And when you're talking about time, you're talking about something that's much more complicated than space, because space has a definite definition when you define it by the proton. The proton and space define each other. But time is not the reciprocal element. Einstein proved that time can be orthogonalized to cubic space, but then you need hypercalculus. And you also can't visualize it. But if you begin with a correct spheric basis, you can actually discover that you're not talking about a relationship directly between space and time. Instead, what you're trying to correlate is space and energy. You could say that another way, space and motion. You can say that another way, which is geometrically the correct way to state it. It's the relationship between space and centrifugal force manifested as angular momentum. Those define each other. Okay? And that's called energy, and it's not spatial. So where does time fit in? It's a derivative of the energy system whereby you can posit something called time in order to understand cyclic motion. And that's what time actually is. So you could say time, energy, and angular momentum and centrifugal force are related. That is a huge insight, and we're going to pass that by for now. As so many of these insights, we must just leave this for future discoverers to capitalize on these insights. I merely am bringing out the structure that can now be used. It can be used. It's a closed, consistent number system for the sphere. And that's the only way to even discover any of this, because angular momentum occurs on a sphere. And that's the definition of the electron. It's also the definition of a photon minus the centripetal force binder. So I hope you like that. That's very suggestive, but it's all been validated, well, to a certain threshold. All right. So the EFE is unusable except by supercomputers, and it can't be understood unless you can visualize pseudo-hyperbolic geometry. I've discussed the light cone in past lectures, so you can at least try, if you want, to understand the linear solution for a spherical phenomenon. Then we can deduce that time is the derivative of angular momentum, that being the physical measure in the domain of centrifugal force. Then we can deduce the true nature of gravity as protonic centripetal force. These are the two balancing forces of universal physics. What we wish to explore further is the chiral, and I finally discovered I've been mispronouncing it all these years. Not an uncommon thing with me, seg. I always would say seg, till my sister said it's Segway. Well, it's not chiral, it's chiral, or chiral. The chiral relation between two forces, which leads us to the flight of the photon, on which I've given several lectures, all going a little further into this new system. But here I'm giving it all to you at once, so you can see the connectedness. I hope you realize by now that this is beyond profound. This is a new dimension of profundity, that this will release the logjam both in astrophysics and in microphysics, that we'll understand now what we're seeing in the only way we possibly could. You have to listen to the universe. So this is also a moral indictment against scientists who don't measure up to the level of David Bohm. And I would include Bernardo Kastrup, except he's a coward, so he doesn't even believe his own philosophy. So I have no more tolerance. I have no more patience. You either come across, or it's one side or the other. You either go the right way or the wrong way. David Bohm went as far as he could the right way. The Dalai Lama approved of him. Bernardo Kastrup made it to a certain threshold, beyond which his immaturity, under the pressure of the monster Tim Maudlin, the demagogue Tim Maudlin, Bernardo folded. That's no good in science. That means you have a personal vested interest. You're a narcissist. And both those men are narcissists. And now, to conclude our lecture. Then we can deduce the true nature of gravity is protonic centripetal force. That's the unified field theory. I got it. That's the answer. These are the two balancing forces. What we wish to explore further is the chiral relation between these two forces, which leads us to the flight of the photon, which has a linear characteristic, doesn't it? That's how we get the measurement to a star, is by the linear flight of a photon. Absolutely impossible. Absolutely impossible. That is an impossibly straight line. So that actually is the quantum paradox. Everything about the electron and entanglement and superposition can be instantly solved by solving the problem of the flight of the photon. That's what I've done. The radial force line of gravity is perpendicular to the sphere. You prove that every time you stand up from your chair. So this can be taught to children, I believe, all the way down to the 5th grade. And that's just, I'm not sure, but I believe so. And I intend to test that out. Because this is an orthogonal relationship, celestial mechanics is fully defined on orthogonality, as Kepler, Newton, and Einstein proved. However, this corresponds to the orthogonality of the two primary forces. Therefore, we have a new insight into photonic manifestation, and that may not be apparent what I just said there, but I wanted to leave this off with something open-ended. There's an old Zen saying that in a good conversation, don't explain everything. I believe David Bohm lived by that, and I believe the Dalai Lama noticed that David Bohm lived by that, and the Lama was pretty impressed with David, was he not? How would you like your book to be dedicated by the Dalai Lama? All right. We have a new insight, giving a robust mechanical framework for defining light speed. That will be in the next lecture. It's going to blow your socks off, because you're finally going to understand why light travels at that speed. And what kind of travel is that? That it goes directly from the atom in a star 10 billion light years away, goes on a dead straight line, arrives at your eye, and you can see that galaxy. That's kind of miraculous, isn't it? Yes, it is. Very miraculous. But it's the duty of a rational man to explain it to whatever threshold of understanding can be achieved. And that's the blueprint we were given by our designer, so that we would have something to do for all eternity, as I like to think about it. Because if you have love, and now you're safe, now what? What are you going to do now that you're protected and have love, and you're, wherever you think that is going to be? You better have something to do, or it's hell. Eternity would be hell. Without rational logic. We're constrained to say that. I do say it. If it's disproved someday, it'll be because someone got further than I did. May that day be tomorrow, but it probably won't be until at least this summer. But you know this now. Tell people to watch this. Tell people to subscribe and to give likes. I don't get any money for it. Tell them that too. If you want to be part of this game, and I leave you with a quote that I just read, and I'm not sure if it's from the Dalai Lama or from David Bohm. It says, live in the moment, because this moment is part of eternity, and therefore, all right, keep looking up. When the skies part at night, look up. Look at the stars, look at the moon, look at the planets as they change position. Stay up all night if you can. Just lie on your back for hours. I've done it. To see the galaxy move through the sky. Of course, you have to choose the right night. Be sure it's not raining, or you could get hypothermia and die. All right, this is Anagalactic, bringing you the secrets of the universe. along with a caveat so you protect yourself. All right? Be on your guard, but also be open. Not easy to do. I would say good luck, except I don't believe in luck. You got it.